Okay, now let's see arithmetic operations. Arithmetic operations can be performed on int, float, and characters as well. Now, you would say, characters, how can we perform operations on them? So, characters are not stored as it is in C. Instead, their ASCII values are stored. So, if we store F or G, their ASCII values will be stored in the variables instead. So now if we perform any addition on characters, the characters will not be added, but instead their ASCII values will be added. Hence, we can definitely perform any arithmetic operations on character values as well. Now another thing to note is there is no pre-assumed operator in arithmetic operations in C. In layman terms, we can say that we often write C into D or C into D as CD in maths. But in C, we need to explicitly specify the operators. So we need to write C into D if we want a multiplication operation. Now, in C, there is no exponential operator, that is, we cannot use any operator to perform this exponential operation. So, for this, we need to perform two steps. To perform exponentiation, first step is to include math library. Now, we need to write the include math.h statement to include all the math library functions to our program. And the next step is to use the power function of this math library. Now what does this power function do? If we write power of 3.0, 2.0, then it will raise 3.0 to the power of 2.0. Now one drawback is that this power function only works on real numbers. So we cannot write that power of 3, 2 because power function will not support the integer constants. It only supports real constants. So we need to convert integer into real before using this power function. Now what happens when we use integers and float together? If we use any arithmetic operation between integer and integer, the output will be integer only. Similarly, between any float and float constant, output will be a float constant only. But then, if we perform a mixed operation, that is, if we use any operand, any operator between an integer and a real number, that is a float number or a double number, then it will always yield a float, that is a real constant. Here by float I meant real constant. So now how does this happen? Whenever we use an integer operand and a real operand, the integer operand will be first promoted to a real, and then operation between these real operands will be performed, and hence the output will be a real operand, a real constant. Okay, now let's come to the assignment operation. Now in assignment operation, there are two parts separated by the assignment operator, which is the equals to sign, the left part and the right part. In left part, we write the variable to which the value of this operation needs to be assigned. And in right part, we can write any constant value or any other variable whose value we want to assign to this variable, or any expression. Now it may so happen that the type of expression on the right hand side and the left hand side may not match. Let us understand this by some examples. Now for example, we write int a float b, and then we write a is equals to 3.5 and b equals to 30. Now note here that a is a integer constant, it can only hold a integer value, and b is a float constant, that is a real constant, it can only hold real values. But here we are doing the opposite, we are assigning integer constant, we are assigning a real constant to this integer variable and real constant to this integer variable. I'm sorry, I messed up. We are assigning the real constant to this integer and integer to this real. So now what will happen is, let us take the first statement. In the first statement, what will happen is 3.5 is a real constant. It will be demoted to integer constant and then it will be assigned to the integer variable I. I will hold the value 3. Now in the second statement, since b is a real variable, then it can only hold real constants. So then 30 will be promoted to a real constant 30.0, and then this value will be stored in the real variable b. So in this format, the values of expression on the right hand side can be either demoted or promoted depending on the type of variable on the left hand side. Now these were some simple examples. In case of some complex expressions also, for example int s float a b c. Now say s is equals to a into b into c into 100 divided by 2 plus 25. Now this expression contains some integer constants and real constants. So what will happen is, as we discussed earlier, whenever integer and real constants are operated upon by use of some operator, then in that case integer constant will be promoted to a real constant, and then the result of such operation will be a real constant only. So here a, b, c are real but other constants are integers. So integer constants will be promoted to real and the result of this expression is going to be a real constant. But now the problem comes that on left hand side our variable is of integer type. Now integer variable cannot hold a real constant. So this real constant will again be demoted to integer constant only, and hence this integer result will be stored in this integer variable. So at the end s will store a integer value only. Now let us look at some examples. Consider a variable k which is of type integer and a variable a which is of type float, that is a real variable a. Now if we write k is equals to 2 divided by 9, then the result is of course 0, and since both of the constants are integer only and left hand side also is a integer constant, hence 0 which is also integer will be stored in k. Now if we write k is equals to 2.0 divided by 9 or 2 divided by 9.0, then in both the cases one of the operand is of real type. But since on left hand side the variable is of integer type, Finally, only the integer value will be stored. Now, even if both the operands are of real constant type, then also the operation will result in a real value. But since LHS contains an integer variable, then it will store only a real integer value. Hence, the real value will be demoted to a integer value. Now let's look at the variable a, which is of type float, that is a is a real variable. Now if we write a is assigned the value of 2 divided by 9, then since 2 and 9 both are integer constants, then this means the output will also be integer only. But since a is a real type, then it will store a real value, hence 0 will be promoted to 0.0. Now if any of the operand is of real type, then this operation will result into value 0.0, and since the variable is also of real type, it will be stored as it is.